Did you know that Nvidia is investing $90 billion into a technology that could outperform all current AI systems combined? This isn't just another chip upgrade, it's a complete overhaul of how computers communicate and process data. The technology is called photonics, and it uses light instead of electricity to transfer information. Imagine a world where your computer doesn't heat up, doesn't lag, and can process data faster than any human could ever dream. That's the promise of Nvidia's massive investment. Right now, most of our computers use electricity to move data through wires, a process that's slow, inefficient, and generates a lot of heat. But with photonics, data could be sent across chips and systems using light, making everything faster, cooler, and more efficient. This could change the entire AI industry, from how we train models to how we use them in real-time applications. Here's the part most people miss. This isn't just about speed. It's about making AI accessible to more people, more industries, and more parts of the world. And here's where it gets interesting. To understand why Nvidia is investing so much in photonics, we need to look at the current limitations of AI hardware. Right now, most AI systems rely on traditional silicon chips and electrical signals to process data. But as AI models grow more complex, these systems struggle to keep up with the demand for speed and efficiency. Think of it like a highway that's getting more and more traffic. Eventually, it can't handle the load anymore. Photonics could be the solution to that problem. Instead of using electrons, which slow down as they move through wires, photonics uses light particles called photons. These can travel much faster, with less resistance, and without generating as much heat. This means AI systems could process data in real time, making things like self-driving cars, medical diagnostics, and real-time language translation much more reliable. But here's what most coverage gets wrong. This isn't just about speed. It's also about making AI systems more energy efficient, which is crucial as the world tries to reduce carbon emissions. And that's just the beginning. So how exactly does photonics work in AI systems? Let's break it down. In traditional computing, data is sent through copper wires using electrical signals. This process is limited by the speed at which electrons can move and the heat they generate. Photonics, on the other hand, uses light to send data through fiber optic cables or even within the chip itself. Think of it like sending messages through a laser instead of an electrical current. This allows for much faster data transfer and significantly less energy consumption. In AI systems, this means that models can be trained and run more efficiently, reducing the time and resources needed. For example, training a large AI model like GPT-4 today could take weeks and require massive amounts of electricity. With photonics, that same process might take days or even hours. This is a game changer for industries that rely on AI, like healthcare, where faster processing can lead to quicker diagnoses. And this is where things get surprising. Let's look at some real-world applications of photonics in AI. One of the most promising areas is in autonomous vehicles. Right now, self-driving cars rely on a mix of sensors, cameras, and traditional computing to process data in real time. But with photonics, these systems could process data faster, allowing cars to react more quickly to their environment. This could reduce accidents and make self-driving technology more reliable. Another example is in healthcare. Medical imaging and diagnostics often require massive amounts of data to be processed quickly. Photonics could allow hospitals to analyze scans in seconds instead of minutes, leading to faster and more accurate diagnoses. In the world of data centers, photonics could reduce the amount of energy needed to run AI systems, which is a huge win for sustainability. And here's the twist nobody expected. This technology isn't just about performance. It's also about making AI more accessible to people in developing countries, where access to high-speed internet and computing power is limited. This is where the real story starts. Let's compare photonics with traditional computing. Traditional systems use electrical signals to transfer data, which is slower and generates more heat. Photonics, on the other hand, uses light, which can travel faster and with less resistance. This means that data can be processed and transferred at much higher speeds. In terms of energy efficiency, traditional computing is much less efficient. The heat generated by electrical signals requires additional cooling systems, which consume more energy. Photonics, by contrast, uses less energy and produces less heat, making it more sustainable. For AI applications, this means that models can be trained and run more efficiently, reducing both the time and cost involved. Another key difference is scalability. Traditional systems have limits on how much data they can process at once, while photonics can handle much larger volumes of data without slowing down. This is especially important for industries like finance and healthcare, where real-time processing is crucial. And this is what nobody's talking about. The implications of Nvidia's investment in photonics are huge for the AI industry. First and foremost, it could lead to a new era of computing where AI systems are faster, more efficient, and more accessible. This could revolutionize industries like healthcare, where faster processing can lead to quicker diagnoses and better patient outcomes. In autonomous vehicles, photonics could make self-driving technology more reliable and widespread. For data centers, the energy savings could be massive, helping reduce the environmental impact of AI. Another important implication is the potential for AI to become more affordable. Right now, training large AI models is expensive and resource-intensive. With photonics, the cost of training and running AI systems could decrease significantly, making AI more accessible to smaller companies and developing countries. This could lead to a more equitable distribution of AI technology, which is a big deal in a world where AI is becoming more and more important. And this is where the real change happens. If you want to stay ahead of the AI curve, there are a few things you can do. First, keep up with the latest developments in AI hardware and photonics. Follow companies like Nvidia, Intel, and others who are investing in this technology. Second, consider learning about the basics of photonics and how it works in AI systems. There are plenty of online courses and tutorials that can help you understand the fundamentals. Third, stay informed about the applications of this technology in different industries. Whether it's healthcare, finance, or autonomous vehicles, photonics has the potential to make a big impact. You can also look into investing in companies that are developing photonics technology, as this could be a lucrative area in the coming years. Finally, don't be afraid to ask questions and engage with the AI community. The more you learn, the better positioned you'll be to take advantage of the opportunities that photonics and AI will bring. And this is where it all starts. The future of AI is here, and it's powered by light. Nvidia's massive investment in photonics is a sign that we're on the cusp of a new era in computing, one that's faster, more efficient, and more sustainable. This technology has the potential to change the way we use AI in every industry, from healthcare to transportation to finance. But it's not just about the technology itself. It's about the opportunities it creates for people and businesses around the world. As photonics becomes more mainstream, we can expect to see a wave of innovation that we've never seen before. This is the moment when AI truly becomes accessible to everyone, not just the biggest companies and wealthiest nations. The journey has just begun, and the possibilities are endless. So, what will you do with this knowledge? The future is bright, and it's powered by light.